Let's look at OpenStax College Physics, Chapter 22, Problem 68. The figure below shows a long straight wire just touching a loop carrying a current I1. Both lie in the same plane. A. What direction must current I2 in the straight wire have to create a field at the center of the loop in the direction opposite to that created by the loop? B. What is the ratio I1 over I2 that gives zero field strength at the center of the loop? C. What is the direction of the field directly above the loop under this circumstance? So we don't know any values. We don't have any values for anything here. So I can't really write anything in my notes. But I have this current I1 going through this loop. I have a current going through this wire either in this direction or in the opposite direction, and we have to figure that direction out. So I'm not going to write anything out in the knowns. I will just write my unknowns. So in part A, I want the direction of I2 such that B2 has a direction that is opposite to B1, such that B2 is in opposite direction of B1. In part B, I want to find the current I1 divided by current I2 so that the net magnetic field is 0 at the center of the loop. And in part C, we want to know the direction of the magnetic field above the loop. All right, so I want in part A the direction of this current so that it creates a magnetic field in the opposite direction that this current creates in the loop. So then let's first find the direction that current 1 creates inside the loop. So we'll use the second right-hand rule where we place our thumb in the direction of the current and then put our hand inside the loop. So that means that when we do that, our fingers are going to stick out in the loop here. So the direction of the magnetic field 1 is out of the loop. So that means that we want the direction of magnetic field 2 to be into the loop. So then what is the direction of the current? Well, now we place our hands, our fingers, our bent fingers inside the loop, and our thumb is going to go in this direction then. So this is the direction of I2. So we're done with part A. Now in part B, we want to know the ratio of I1 to I2 so that the sum of these magnetic fields is 0. So I have one magnetic field coming out, another one going in. So if I set those two equal to one another, then I know that the net magnetic field is 0 inside the loop. So I'll do B1 equals B2, and B1 is mu naught I1 divided by, so I1 is a loop. The equation for that is just 2R. So it's mu naught I1 divided by 2R. And the magnetic field 2 is due to a wire, so that is mu naught I2 divided by 2 pi R. So when I divide I1 by I2, everything cancels out except for the pi. So I1 divided by I2 is 1 over pi. So now we are asked to find the magnetic field above the loop, so somewhere here. We know that we ignore edge effects for loops of wire. So we only have magnetic fields inside loops of wire, and that would be out of the page. So the only magnetic field that exists outside the loop is the magnetic field due to current 2. So everywhere on this side of current 2 the magnetic field is going to be into the page, and on this other side of the loop, the magnetic field would be out of the page. So the question is, what is the direction of the magnetic field above the loop? Well, that is into the page. So the answer to part C is into the page.